In Fusion 360, whatever the files you are going to create, it may be a sketching or it may be a 3D modeling or assembly files, right? All those things you are going to save it. In Fusion 360, we can save the file either in cloud, or if you want, you can save it in your local system also. For that purpose, first we need to create a new project, and what are all the things we are going to create it, right? That will be saved in that particular project. Okay, so now I will show you how to create a new project. So you go for left to top. Here you are having show data panel. You please click on that, and here you are having a new project. You select that new project, right? And now we need to give name for our project. See, my project name is what, Medini underscore VTU. Okay, now whatever the files I'm going to create, right? All the things will be, I'm going to save it in this Medini underscore VTU project, and now I'm going to pin it. Okay, see, if I pin it, what happens? It comes to the top. Okay, and now uh, see, you can observe here. See, at the top here you will have that project, that is Medini underscore VTU, and I will open it. And now see, I'm going to add other folders here. Okay, now first I will show you how to create a 3D modeling of the screw jack assembly. Okay, and now see, I will click on new folder. See, the folder name is what, screw jack. Okay, and here see, I'm going to rename it screw jack. Okay, yeah. See, this is what my sub project. Okay, see, Medin underscore BTV is what my main project. In that, the sub project is what, a screw jack, and I will open that particular project. And now I'm going to close it here. See, close the data panel. See, now what are all the things I'm going to save it, right? That will be saved in that particular screw jack folder. Okay, and now see, when you go for any sketching of any assemblies, right? Or else if you go for any part modeling, right? At that time, if you input that particular image into your screen, right? That sketching, that is platform, what happens is it will save time. Okay, and now I will show you how to input the image in Fusion 360. Okay, now here you are having one tab here. See, that is insert tab. Okay, you please click on this insert tab. Here you are having option canvas. Okay, by using this, what we can do is you can input the image. Okay, and by taking that image as a reference, we can do our sketching. Okay, now here in the browser, you please observe, here you don't have any folders, right? Here, like canvas. See, document setting is there, views is there. And now before going to input the image, I will show you how to do the unit settings. Okay, here you please open this folder, that is document setting. Here you click on edit. Here, see, unit type is what, now I have selected millimeter. Now if you want any centimeter, inches, foot, right, you select that particular unit and you click on OK. Okay, and now see, after setting the units, you need to go for, see, insert image. See, insert, you go for canvas, and see, when you select that canvas, now it will show you how, see here, location. Okay, see where you have saved that particular image, right? Whether you saved in cloud or it may be in your local, that is computer. You just input that image. See, my image in my laptop. Okay, in the desktop. See, insert from computer. And here, see, in the desktop I have one folder, assembly photos. In that, screw jack is what the subfolder. Here I have that image. Okay, I will select that image. Okay, and I will select one particular plane. Here I will select front plane, because I'm going to do the sketching in front plane. That's why I will select that. Then I will click on OK. See, the image is here. Now I will go for sketching. See, go for create sketch. You select that front plane, and now here you can see here. Now what are all the commands you need to for the sketching, right? All things are here, and here the image is also here. See, now I want to resize this image. At that time, here you can observe here, since we inserted the canvas, that's why insert canvas folder is here in the browser. You open that canvas folder and you please select that body image, and you just right click on edit canvas. By using this, what you can do is you can resize that image, and also you can flip the image. Now I will place that particular image to a particular position. Wherever I want, I can place it. And if I want to increase the or if I want to resize it, okay, now I want to increase the size. See, you just select the corner and you just drag it here. See, and also here you can observe the dimensions. Okay, they are what flipped. Right now I want to flip this image. If I flip that image, the dimensions will become correct. See, like this. Now again I want to place this image to a particular position. See, like this. Okay, by using here, okay, you click on OK. By using calibrate also you can that is resize that image to a particular the value whatever they want. You can do it by using this calibrate. Okay, and now we all know what is the total height of the body part. See, the total height of the body part is what? 185 mm. You go for here create, you select the line command, or else the shortcut key for line command is what? L. You select L, line command. See, line is command is selected. You go for origin, you select the origin and you draw a line of 185 mm, because that is what the height of the body part. Now see, by taking this height as a reference, now once again I'm going to resize that image. Okay, because by taking that image as a reference I will do my sketching. Then again, see, canvas, you select the body, edit canvas, and you select the corner and you just drag it like this. See, so you can drag it. Okay, now I will click on OK, and now I will start from the top here. Okay, the top you can observe. See, this sketch, the inner diameter is 50 mm, outer diameter is 70 mm. See, it is a symmetrical object. As we all know, symmetrical object will be we can create by using a revolve command, right? See, in order to if you are creating any particular part by using revolve command, you need to create only half part. Okay, and we will taking one axis of revolution as a reference and we will revolve it. So here in this particular image we are going to create only this hatched portion. Okay, now see, I will select that is L. See, line got selected, that is shortcut key. Now see, inner diameter 50, see 25 mm, right? See, we are creating half portion, so 25. See, 25. Then the outer diameter is what? 35. So that is 70 by 2 will be 35. So 35 minus 25 will be 10. So now I need to draw a line of only 10 mm. Okay, now I am here. Now I need to move downwards, vertically downwards. The height is how much? That is 40 mm. See, 40. And also here you can observe angled line is there here. See, the dimension of that is here. Inner they have given 66 here. See, this one 66. This outer is what? 70. Right? 70 minus 66 will be 4. 4 by 2 will be 2. And angle will be what? It will be 45 degree or else 135 degree. Okay, that is 2 mm distance, and I will press tab. Now it will be shifted to angle, that is 135. Okay, here by using that scroll button I'm going to zoom in. See, here I'm going to place this. Okay, now I want to come out of a line command. Okay, you are having two ways. Okay, one is that you just press escape, you will come out of line command, or else mouse right click and you click on OK, you will come out of that command. Now I will continue my sketching from the bottom. Here see the bottom diameter you can observe. See, the total diameter is 140 and here the inner is what? 100. So 140 by 2 will be 70. So I am going to draw a line horizontal direction 70 mm. Then see, from here to here that is 70. Then the height is how much? That is 20. Now I will moving inwards here. See, this distance is again 20 here. See, that is from here to here, this is here 100 is there overall inner, and outer is 140 is there. 140 minus 100 will be 40. 40 by 2 will be 20. This one will be 20. So 20, and you just join here. See, like this, just zoom it by using scroll button. Just zoom it and you connect it. Okay, and now I will press escape button, so I will come out of line command. And here you please look this sketch. Here it consists of some constraints like horizontal, vertical, angled, and also dimensions. Now we see, if you want to hide anything, right? Like if you want to hide constraints, here you just uncheck it. See, the dimension, that is the constraints got hidden. Now if you don't want any dimensions, you just remove it, say you can observe like this. Now I want dimensions, I will keep it. And here another thing is that here, see, we left only that radius, right? 8 mm is there, that we can add it in sketch only, or else in the 3D only you can add it. Okay, now what I will do is I will go to revolve it. Okay, see, before revolving, as I told you, we are creating only this half portion, that is hatched portion, right? For that purpose, what we can do is, first thing is that we will hide the dimensions, and by using this offset commands here, we don't have any the proper the dimensions here, right? But we know the distance in between is 10 mm. Now what we can do is we can make use of offset command. Go for offset command. See, if I move my cursor on the line, right? See this one. See, this is the line which I want to offset here. I want to offset it inside. See, I will add 10 mm. See, if I add 10 mm, it will be outwards, right? If you want to flip it inside, you have a flip option. You select flip option, you flip it. Then, see, this warning is because of dimensions got hidden. That's fine. Then no, you need not to worry about that one. Then again, offset this line will be inside. That is positive 10 mm. See, that's it. You click on OK, and now see, now we want to extend this line, right? For that purpose, you go for modify tab, you select extend, and you select the line. See, like this. And now here also you need to extend the line, right? Just extend. And also here you need to observe here. See, 3 mm line is there, and this is length is how much? 50. So again, line command. See, line command. See, height is how much? 3 mm. 3. Okay, and here you zoom it, and here this horizontal distance is how much? 50. See, 50. That's it. And now we need to trim the extra lines here. See, what are the unwanted lines are there, that we need to remove. For that purpose, we can make use of a trim command, which is available in modify tab. See, select trim, and you just trim all the unwanted lines. See, these are the unwanted lines, because at the beginning only I told you that we are creating only half, that is hatched portion. See, only this hatched portion we need. Okay, like this, you just trim all the extra lines here. See, that is unwanted lines. Now I will see here. Now I don't want this image, and also you please remember this radius, this corner radius is what? 8 mm. Okay, now what I will do is I will hide this image here. I symbol is there, you just hide it, and you click on finish sketch. And as we know that we are going to revolve it by using the revolve command. You select revolve command, and see, since the profile is closed, right, the profile is what automatically got selected, and axis is what? This vertical axis. See, like this, and you click on OK. And now see, we need to provide radius here, right? That is affiliate here, right? That you can add it in sketch also. Now see, I want to add it by using this that is 3D radius fillet command. I will select, and I will select this edge, and the radius is how much? 8 mm, right? That is 8 mm. Okay, after this we need to that is, we need to convert this body into what component. Okay, how to convert that body into component? See here, you are having a folder that is body. Okay, here you just right click, and you can convert that body into what? Component. See here, right click, in you can convert it into body. That is component. Body will be converted into component. See, before that we can add the material also, that I will show you how to add the material and how to add the appearance. Okay, so you go for modify. Here you select physical material. Okay, here you are having the one window here. You can observe here. See this one. Here we'll go for the metal, and see, we all know the body is made up of what? Cast iron. Okay, we need to apply cast iron material. Here, see, we'll get the folder, metal folder. You just open it, and here you have the, see, physical material, right? That is, we need to add iron, that is cast iron. See, iron cast is there. You just add that cast iron as a material. See, now the color has been changed. At the same time, see, if you want to know about the properties of cast iron, right? At that time here, see, you go over here, just right click and you click on edit and you please select advanced and here physical. See in the physical here you can observe what are all the thermal, mechanical and strength. What are the properties of that cast iron is there. See all the things are here and this particular body part now it is made up of cast iron and it contains all these properties. Okay. See if you want to change anything. Okay, in any cases if you want to modify the properties at that time you can modify it. Okay, then close. Now again I will go for modify. Here you please observe we discussed about physical material, right? Now we'll go for appearance. Appearance. Now see now I don't want this appearance for my that is body part. I want to add other appearances or other that is colors. Okay. Now here you please observe. See the same bit or whatever the window you got for physical material, the same thing is here, but here it is what only about appearance. Okay. Now this body part it is made up of what cast iron, and now I want to add the what appearance, and now I will add the appearance as a what see copper. Okay. How to add it? You just select it and drag and drop it. See like this. Now this particular body part of screw jack it is made up of cast iron and it is having the appearance of what copper polished. Okay, see like this you can add the physical material and also you can add the appearance. See now after this, see we'll convert this body into a component. See it is a good practice when you go for any that is industrial that is a design center. At the same time, see after doing all the modifications we need to convert that body into what component so that we can add the properties. That again I will show you. See first you just rightly you select that body folder, you rightly see create component from bodies, you click on it. Now see the component that is here. Now I want to add some properties for this component. See like you just right click and here you go for components, sorry properties, you select the properties. Here see part number I want to add a part number 1 and part name that is body. Okay, it will be helpful. See here material name is what cast iron and physical properties, all the things are here and it will be very helpful when you go for the drafting. Okay, when you take that is the table, right? At that time all the things will be what it will be appear in that drafting. Okay, please click on close. Okay, see now the name has been changed to body. Now what we'll do is we will save this. Okay, you go for file, click on save. Okay, now here see the file name is what I will take it as a body and location you can observe. See Medini underscore VTU and screwjack is what that is subfolder or sub project. And if I click on save, right, now this file has been what it will be saved in that folder or project. See here file name is also changed body. And now how to check where we have saved, right? You go for again show data panel and here you can observe, see body Medini underscore VTU is what project, in that the sub project is what screwjack. In that we select, we created body and we saved it. See, okay. So this is how to make a part modeling of the body of a screw jack. And next we will discuss about the second part. Okay, thank you. The second part in screw jack assembly is what nut part. See this is what the nut part image. First you need to take this image by using a sniping tool, and after that you please insert that image into the Fusion 360, that is the plane, so that will be very helpful when you go for drawing. Now I will go for insert tab. I will select canvas and I am going to insert that image which is available in my local computer, that is nut part, and I'm going to place that image on the front plane, so that by selecting that plane only I will go for sketching. Okay, see create sketch, I will select the front plane, and now first I need to resize this image. Okay, as I told you in the earlier, in the browser, there is one separate folder is there, that is canvas. In that, you are having the image nut, and you need to resize it by selecting edit canvas. You select edit canvas and you place it to proper position, and you just stretch it by selecting the corner, and here you just flip it. See, now dimensions are clearly visible. Now what we will do is, see, first thing is that we know height of this nut part, right? That is the height is 45 mm, right? Now you please select line command. From the origin you need to draw a line of 45 mm. Okay, see, 45 like this. And after that, if you want, you can again, once again, you resize this image. Okay, you keep it to a suitable size and to a proper position like this, and you just continue. Now see, they have given this diameter is 50 mm, and this diameter is 90 mm, and also we are going to create this part by using the revolve command, so that we need to create only half portion. This hatch portion we need to create. Please select line command. From the top, first I will draw that 50 mm, that is 50 mm diameter. So half will be 25, so 25. Then downwards here. See, now I am here. See, this height they have given 10 mm, right? 10 mm. Then this outer. See, total that is the outer they have given 90. 90 half will be 45, and in that 25 already done. So 95 half is 45. 45 minus 25, it will be 20 mm. So now I need to draw 20 mm. Then this height also they have given, that is 10 mm. Okay, this again the same thing, that is 20 mm, and you just join. Okay, see, like this you just join. Now see, it looks little clumsy. You do one thing, you just place the dimensions to a proper position. At the same time, you just hide the constraints. Okay, see, now it is clearly visible. Okay, and also here they have given thread. You need to add a square thread which is having diameter 38 into 7. That is what the specification, and diameter is 38 mm. 38 mm half will be 19 mm. So here this diameter they have given, that is total 38, half will be 19. So once again you go for modify, you please select offset command and you select this wood line. See, when I move my cursor on this sketch, right, see the whole sketch got selected. That is because of here chain selection is what switch on. Now what I need to only this particular that is line has to be offsetted, right, that 45 mm height line. You just do one thing, you just uncheck this chain selection and you select the line and you just offset it for a diameter of 19 mm, right, and you please flip the direction like this. Yeah, this is what the sketch we need. And now we will delete the unwanted lines. We will remove the unwanted lines by using this trim command. So please select trim command and see, you delete all the lines, right? And here I will click on finish sketch. At the same time, you please hide this image if you want to keep it, otherwise just hide it. Okay, now also here they have given, see, this radius also they have given, that is 5 mm. Okay, and also square thread 38 into 7. Okay, fine. Now I will hide the image. I will go for revolve command. We will select the axis. See this. Here again I need to provide a fillet, right? See, fillet for this and these two edges here. One, see, like this. This is how much? 5 mm, right? That is 5. Okay, and also for this inner cylinder we need to provide what? The hollow part here we need to provide a square thread. For that purpose, you say go for create a tab. You please select hole. Okay, not hole, that is thread, right? We need to provide thread. You please select thread and we select this inner cylinder. And here we need to provide a square thread. For that purpose, I will take this isometric trapezoidal thread, and they have given TR 38 into 7 is what the specification. And you please switch on this model. Okay, otherwise what will happen? You will get a shaded thread. See, now I won't switch on that model. Now you please observe the thread what you got here. See, it is a shaded, means what, you don't have a real view, you have a shaded view. For that purpose, what you need to do is you go for timeline. Once again, you edit this whole feature. You please select model and you click on OK. See, square like this. Okay. See, after that, what you need to do is you need to provide a what, that is material, and after that you need to go for, that is you need to convert that body into component, right? See here, see nut part. I'll go for again here. See, for nut part I will take steel as a material. Okay, no need to worry. That is, I will go for physical material. Okay, here default there will be a steel, and here what I will do is steel. Okay, stainless steel. I will take stainless steel. I will add that stainless steel as a material. Okay, close. Material is also added, and if you want, you can add the what, appearance, right? Appearance. I will go for see again. See here metal, and here I will go for brass. See, I will add brass as a material. See, it looks good, right? Now material has been added, and also this we added a good appearance for that particular nut part. Now we'll go for we'll convert this body into what component. You just right click here, you click on create component from bodies. Now the body is converted into component, and again you just right click here and add the properties. That is, this is the part number 2. Part name is what, nut, and see material stainless steel. Okay, then please close this. Now what we will do is we'll save this, right? Go for file, click on save. This is the second part, that is nut. And what is the file location? Medini underscore VTU. That is what the our project name. Save. Okay, thank you. The third part in screw jack assembly is what, screw spindle. As we know how to insert that is image into Fusion 360, that is workspace. You need to select wherever you save that particular image, right? That you need to select, and you need to click on open. Then you please select the plane. Okay, and after that you click on OK. Then create sketch. Then you please select the front plane on which we have placed the image, and again here in the canvas you please resize that image. Okay, edit canvas, and you just resize it. Okay, and you just flip it, and here now what is the total height of this particular screw spindle? It is 240 mm. Now I will draw a line, vertical line of distance, that is 240 mm. And now I'm going to place this particular image to a suitable position, and for a suitable size. Okay, see, like this I will place it. Okay, and I'm going to increase the size like this. And now see, we'll start the creating this screw spindle sketch. So please select line command, and I will start from the top. You please observe this diameter is, they have given 22. So I will take that is 11 mm, that is half. Then this height, see this height they have given that is 13 mm. Okay, see that is 13 mm. Okay, and after this outer, the outer you please observe is 65 is there. 65 half will be 32.5, right? Then 32.5 minus 11, it will be 21.5. See, 21.5 like this. Then this height here, this total height they have given, this is 83 minus 13. 83 minus 13, that is 80 mm or 70 mm, not 80, that is 70 mm. See, 70 mm. Then you just draw a horizontal line like this. And now we'll start from the bottom. See, the bottom they have given the diameter, you please observe, it is 38 into 7, that is what the thread specification. And before that diameter is 38 is there, half will be 19 mm. So I will take 19 mm. Then I will just draw a vertical line like this. Okay, and now I will delete the, or I will trim the extra lines here. Okay, see, these are the unwanted lines here. See these, yeah. Okay, and now see, I will click on finish sketch and I'm going to revolve it. Okay, see, create revolve command. Then you select the axis here. This is what the axis. Now click on OK. Okay, and now here they have given some chamfering here. You please observe. Okay, that is 10 into 45 degree. All right. Now here I will go for modify chamfer. See, first edge, second edge. Then they have given distance and angle. See, distance and angle. See, distance is 10 mm, right? See, distance is 10 mm and angle is 45 degree. Please click on OK. Right? And the next one. See, next one we need to provide here. See, thread. Right? Thread they have given square thread, that is 38 into 7. And also here a little chamfer is there. I will select. I will take it as a 1 mm. They have not specified it. I will provide only 1 mm chamfer here for this particular edge. Only 1 mm, right? 1 mm. That's it. Okay. And now I will go for the thread. See, thread they have given 38 into 7, right? The specification is what? 38 into 7. I will select the cylinder and it is a square thread, right? Isometric typical I will select. Okay. I will switch on this model and TR38 into 7. See? Okay. Right? See, threading is over. Now after that, here you please observe. Here there is one hole is there, right? Through hole is there, which is having a diameter of 12 mm, and from this particular end, it is at a distance of how much? 35. Right? For that purpose, what I will do is here, little I will tilt this the spindle, create sketch. I will select this middle plane. Okay. See here, this is center plane. I will select. You can observe here. See, this is center plane. I will select. Okay. And now, see, circle. See, here you won't get any the reference. So I will move the cursor from the origin. Right now, I will get a reference. Right. That is diameter 12 mm. See, diameter 12 mm. And now the distance, see, from this particular end, it is at a distance of 35 mm, right? 35. Okay. You click on finish sketch, then you go for extrude here. See, please select extrude, and once you select the extrude, the profile is already selected. And here I will take it as a symmetric, and I will just drag this arrow. See, this is a through hole. Okay. Please click on OK. And now the last thing is what here? Hole. See here, countersink hole is there, which is having the end, that is VN, right? Now for that purpose, I will go for here. See, hole. Okay. I will select this top. Here you please observe. See, when I select the center of the hole and if I move towards the center of this the spindle, right here some white wall structure will come. White wall will come. See, that is what the center. Okay, you just drag and drop it here. See, white wall. You just drag it to here. It will be fitted to that particular that is point, that is center. And now we need to add the see dimensions here. See, one thing is that here it is a countersink hole. See, we know countersink hole, and also here some it is a tap door. Okay, and they have given see thread. Thread is not full thread; it is a offset thread, and V notch we need. Okay, and here they have given what is the total that is hole depth. Total hole depth is how much? That is they have given 35. Total hole depth is 35, and hole diameter is how much? That is 12 mm, M12. Then this thread, okay, thread they have given we need up to 30 mm, right? Then okay, see size, how much size? M12. Yeah, M12. See, that's it. These are all the specification we need. You click on OK. Before that, you can select here model, okay, so that you will get a real view. Then okay. See, this is what the screw spindle you need. Okay. See, otherwise what we can do is we take a sectional view and we will observe, okay, how that countersink hole looks like. For that purpose, here in the inspect command, here you are having an option section analysis. You select section analysis, and you select the plane here. Okay, see, like this. Select the plane. Okay, and now here you can observe. See, here you can observe. See, it is a countersink hole, right? Thread is 30 mm, hole depth is 35 mm. It is having a V. And here don't click on OK. You please click on cancel because we don't need any section view now. See, like this, and you please hide the image. Okay, and in the image they have given, it is made up of mild steel. So now I'm going to apply material. Please select modify, come tab, then physical material. In the physical material, you please go for that is mild steel. Okay, here mild steel is there. See, that is a steel. Okay, steel mild. Yeah, here it is available. Okay, please scroll down, and now you will get a steel. Okay, here steel cast is there, steel alloy is there. Yeah, yeah, steel mild. See, mild steel. You just drag and drop it. Okay, you click on close, and now if you want, you can apply the appearance here. You go for appearance, you select it. Now here I will select bronze. Okay, I'm going to apply appearance of bronze. See, like this, bronze. Okay, okay, not bronze. Chrome. Yeah, chrome. Chrome is also okay. We'll go for copper. Okay, it looks good. See, copper. Yeah, like this. Close. Now see, material has been applied. Appearance has been applied. Now color has been applied. Now we go for what? We need to create component from bodies. You just right click here. See, create component from bodies, and you just add the properties here. See, just right click, properties. Here this is part number third part name, screw spindle, right? If you want to add any description, you can add it, steel mile and all the properties, then close. Okay, and now what you need to do is you need to save the file. See, you click on save, right? And here the part name is what? Screw spindle, right? Yes, screw spindle. Then you click on save. See, you please check the location, Medini underscore VTU, save. See, that's it. Okay, thank you. The fourth part in case of screw jack assembly is what cup, and now I will show you how to make a part modeling of cup part. See, first thing is that I'm going to insert that image to the canvas of the Fusion 360, and here I will select the cup part, and I will place that image on the front plane. I will click on OK, and now see, create sketch. You need to select a create sketch, then front plane, and you need to go for this canvas, and you need to resize that image, right? See, like this. You place the that is image like this, and you flip the direction like this, then you click on OK, and the total height of cup part is what? 42 mm. Please select line command. See, the height is how much? 42 mm. See, 42 mm. Okay, see, we can make use of the present size of the image of this part for the sketching. See, the total height is 42 mm, and here you please observe they have given this outer diameter, that is 65. Okay, so from the center to outer, that is 65. Okay, fine. Or else here I'm going to once again I'm going to increase the size of this particular image so that all the dimensions are clearly visible. Click on OK, and now see this outer diameter they have given. See, from here to here outer, that is 65. Half will be how much? That is 32.5. See, line command from this, that is 32.5 mm. Okay, see, 32.5. And now here, see, I will come out of line command by pressing escape. Now see, this bottom they have given, that is 45 mm outer, that is 45 mm, that is half will be 22.5. Okay, and I will just connect like this. Okay, and now I need to offset here. See, I need to offset this line. This is 6 mm, and here this is 12 mm, and this inside is how much? 22 is there. Half will be, that is 11, right? Yeah. And now I will go for offset command. Okay, so I need to offset this line inside. That is how much? 6 mm. See, 6 mm. Okay, and now here from the bottom here offset. See this, that is 12 mm, right? 12 mm. Okay, and now here see this, they have given that is 11 mm, that is 22, right? And now see we'll go for that creating uh, yeah, 11 mm, that is offset command. Again this has to be offsetted to a distance of how much? That is 11. Yeah, flip the direction. See, like this. And now you please here, by making use of this extender, right? You just uh, extend the lines. So extend the lines. See, modify, extend. See, this line has to be extended. This also, right? And now we will trim all the noted lines here. See, don't need this. Yeah, this line, right? And now here this part line, this part of the line. See here, this one, right? See, yeah, okay. And now we'll hide the image, and we'll finish the sketch, and we will revolve it. Okay, this is our the axis. And also in the image they clearly given here, we need to make a hole, right? See, this is radius 5, from the center it is 2. Okay, from all the that is 4. Okay, now I will hide that image, that is radius we know 5 mm. See, yeah, sketch. See this middle planes here, this center plane we need to select. See middle. Okay, this one. And now sketch. See, from the origin you please move the cursor. See, from this center, right, we need to draw a 12 mm circle, but here at the top I'm not getting any reference point, right? So that's why what I can do is here, uh, I can make use of another command here. See, that one, that is what a project command. See, I'm going to project that particular top end, that is top edge. See, project, select the top, then I will click on OK. And now if I go for selecting, that is a circle, and if I move my cursor from the top, right here, see, at the center I will get a reference. See, that is radius 5, so diameter will be 10. So finish sketch, and by using extrude command, okay, you just extrude it symmetrically on the both side. Okay, that is, yeah, like this. Again the same thing, go for create sketch, and this plane. See, this one. Yeah, see this plane, and again same thing. See, circle from this center. See, okay, see, you won't get the reference, then you just project that particular pen. Now circle, see, from this center, that is diameter, that is how much? 10. Finish sketch, please extrude it. Okay, symmetrically both. See, okay, see, this is what the cup part we need. And now what we need to do is we need to apply the material, and we need to apply the appearance, right? Cup, it is made up of cast iron. And now we'll go for modify, physical material. In physical material, cast iron. Please open this metal folder. Here iron cast is there, both are same. Iron cast or cast iron. See, iron cast, drag and drop it. Okay, then close. Now once again you go for modify, because of we need to apply a very good appearance, right? That's why we'll go for see gold. Okay, I will select the gold material, then close. Now what we'll do is we'll convert this body into component. See, right click, create component from bodies. So right click, then you please select properties. And here you need to add the part number. That is part number 4. Then part name. Part name is what? Curve part, right? Then materials iron cast. Then close. And now see, material has been applied and everything is over. Please save this curve part for the assembly. Okay, that is the part name is what? Curve. Location is Medini underscore VTU. That is what my project. So save. Okay, thank you. The fifth part in case of screw jack assembly is what washer part. And now I will show you two method to create a that is washer part. First I will insert that image, okay, into my Fusion 360, that is main screen or canvas. And see, I will select that washer part, open, and I will select the front plane to place it. Okay, then again create sketch, please select the front plane. And by making use of this canvas, right, you just resize, see, edit canvas, you just resize it to a proper that is size and proper position. Please place it to proper position, then you click on OK. And now here they have on this side, that is 32.5 mm. I will select line command. See, from the origin is at height of, sorry, this length is how much? 32 point, that is 35, right? So okay, 35 by 2. Okay, 35 by 2. And this height they have given 8 mm. Okay, and here see this one, here they have given, here you please observe, this up to here, from here to here this is 25. Okay, the total is what? 35. So 35 minus 25, it will be how much? 10, and half will be 5. See, this portion will be how much? 5 mm. So now what I will do is I will draw a line of 5 mm. Okay, at the same time now see here I need to draw this angle line, right? They have given 90 degree. So now here at this particular position I need to draw a line of that is 45 degree. See, 45 degree or else 135 degree. Okay, see, 130, I like this. And now the same time here you please observe, they have given here, see, this length. This length is how much here? From inside they have given it is at a distance of how much? 14.5. Right, see, please select line command, that is 14.5. Right, see, 14.5 by 2, 14.5 divided by 2 mm. See, up to here. Okay, now we will trim all the extra, that is unwanted lines here. Okay, here you can observe. Yeah, once again see, once again I will create this 14.5 mm line. It will be very nice. See, again line command from the origin, that is 14.5 by 2. Right, see, and now again at this particular position I will draw one vertical line like this. And now I will trim all the unwanted lines here. You go for trim command, select all the unwanted lines. Okay, see here this line and this two. See, this is what the sketch we need. Please click on finish sketch, and you please hide the image and make use of a revolve command, and you select the axis. See, this is what the washer. Okay, this is one method. Okay, now I will apply a material for this. Okay, and we will save it. That is washer, it is made up of mild steel, right? That is modify, that is physical material, right? Physical material, then material is what? Mild steel. Go for steel. Okay, steel. So please add that material to the part. Okay, see, steel mild, just drag and drop. That's it. Now we'll apply the appearance, right? The same things, modify, appearance, See, we applied oh, now we'll go for let. Yeah, let will open. Yeah, see this appearance. Okay, this appearance will provide. This is all about appearance, right? So appear. Yeah, that. Then close. Right? Now we will convert this body into what that is a component, create component from bodies, and we will add the properties. That is properties. The part name is what? That is part number is 5. Part name is washer. Okay, and please save this. Yeah, wash. That is save washer. Okay, like this. It has been saved in material_btu. That is what my project. And now I will show you another method to create this washer. That is also very simple. See in the image, we know that. Yeah, I will open that image. Here, you please observe. See here, 35 is what the diameter, and 8 mm is what the distance, right? See, fusion, sketch. Okay, I will select front plane. See, what is the total diameter? That is 35, right? And now, what is that extruded distance here? It is 8 mm. See, 8 mm. Okay. And now here inside you please observe. See, here inside they have given the diameter is 25, and also here the bottom here they have given that is 14.5. 25, 14.5. It is a countersink hole actually. Okay. Once again we will go for here. We select hole command. We place a hole here at the top, and we'll place that hole to the origin. And here you please observe we need to select a countersink hole here. See, countersink hole. Okay, we need only simple countersink hole. See, hole tab type also simple. Drill point also we will take flat. And here, what is the total that is out? This top diameter they have given 25, and here bottom 14.5. Already entered 25, 14.5. You click on OK. See, this is what the part. See, like this. Now after this you can apply the material, and you add the properties, and you can save it, right? You already know about it. This is what the second way to create this washer part. Thank you. The sixth part in screw jack assembly is what CSK screw. Now I will input that CSK screw image into the fusion canvas, and I will do the sketching. Okay, that is screw or CSK screw. Open it, and I will place on the front plane and click on OK. Then again create sketch, then front plane, and I'm going to resize it, create. Okay, so here you go for canvas. Here you please resize that image, and I place that image to a proper that is position. See, like this. Just flip it. See, yeah, like this. Then you click on OK. Now I will select the line command. Shortcut key also I can select, that is L. Okay. Then from the origin I'm going to draw a line. Okay. The total the length they have given, that is 30 mm. So total that is 30 mm. Okay. And here this one, see this height they have given, that is M12. So half will be 6, right? See, 6 mm. Then this one, this also, this length also they have given 30 minus 26, it will be 24. See, and I will press escape, and I will come out of line command. Then again I will select line command, that is I will select okay line. Then from this, see here they have given here, see, that is diameter, total diameter 24 they have given, so half will be 12. Okay, that is 12. Then just join like this. Angle will be 45. See, angle will be 40. And now here finish sketch. Just revolve it. Okay. Yeah, like this. And now see, now we need to make this portion, right? It is having see this depth they have given 3 mm, and in the top view they have given it is 1 mm. See, from the center 1 total. So now what I will do is I will select the center plane here. Okay, I will hide the image. Now see, create sketch. See, I need to select this center plane. See, this one. See, this center. Yeah, this middle plane. See, this middle plane I will select. Now, I will select, say, okay, I will make use of rectangle. Okay, see, center point rectangle I will select. From the origin, I will just draw a rectangle like this. Okay, and now I will give the depth here. This depth from the center to here, the depth they have given 3 mm, right? 3 mm. And now here, see, from this center, see, from here to here, they have given total 2, right? See, 1. So total will be 2, right? Then finish sketch. Then you just place it to a proper that is position, and you make use of extrude, right? Go for extrude and symmetric. You just drag this. Okay, see, and also we need to provide a thread here. Okay, here they have given that is M12. Okay, thread. Now what I will do is I will go for thread, create thread command, select cylindrical portion, select model. Here you go, M12. See, click on. See, yes. And also now I will apply the material that is mild steel. See, you go for modify, right? Modify physical material. Then you select the material that is mild steel, right? Is mild steel. Now see, you just drag and drop it. Close this, and now you just convert this body into what component, that is just rename it. Okay, that is adding the properties, you rename it, that is properties. Okay, that is part number is what, 6. Component name is what, CSK screw. Okay, like this, and material and everything is there. And the next part is what, appearance. If you want, you can apply the good appearance for your particular the part we have created. Okay, go for nickel. Yeah, nickel is also same color. Then platinum. Yeah, silver. Okay, silver. I will apply silver. Okay, see, appearance silver. Then you click on save. Okay, here save it as a CSK screen. The last part in Fusion 360 assembly is what Tommy bar, and now see, this is what the Tommy bar part. Now I will insert that image of the Tommy bar, and after that I will show you how to do the sketching of this Tommy bar. I will place it on the front plane. I will click on OK. Then again I will select create sketch. I will select the front plane, and I am going to resize this canvas. Okay, see, edit canvas. I'll place it to a proper position here. Okay, and here I will just rotate it like this. Yeah, at the same time I'm going to increase the size, and I'm going to flip it. Okay, and now at the same time I will click on OK, and I will draw a line. So what is the total height of this Tommy bar? That is 275 mm. Okay, 275. Okay, 275. Now I will reset that image. Okay, so here edit canvas. See, like this. Please reset it to a proper that is size, so that you can easily make use for the sketching. Okay, now see, the top they have given the diameter 12, so half will be 6 mm. It is 6. Then here the length they have given, that is 62 here, 62, right? And here this is the angle. Okay, here we don't worry about the length, we need to worry about only angle, that is 45 or 130. Okay, we draw a line like this, and now again line command. See, from the bottom here they have given diameter, that is 20 mm. See, diameter is how much, 20 mm. So half will be what? 10. So 10 mm. Okay, and you just draw a vertical line like this. Okay, and here, see this intersection what we need. Okay, and here we just trim it. Okay, this is what the Tommy bar. See, finish sketch, and also here we need to provide a radius, right? 20 mm. Okay, we'll provide it later. See, just revolve, you select the axis, you can okay, and you please hide that image. Like this. And see, they have given this diameter that is 20, so radius will be 10. See, fillet. See, this is 10 mm. See, 10. Okay, here you can observe. See, that is 10. And now here also we need to provide a chamfer. Okay, in the that is a sketch they have not provided. Simply you provide a chamfer of 1 mm. That should be good. Okay, we need to avoid when you go for part mounting. We need to avoid the short edges. Okay, and now we need to apply the material. See, default material it will take a steel, and now here we need to apply the material as a what? Mild steel. See, physical material. We need to apply material as a what? Mild steel. So just scroll down. Here you will get a material steel mild. Here you can observe steel mild. Just drag and drop it. Okay, close. And appearance. See, appearance, as I told you, you can give any appearance whatever you want. It is all about the coloring and every those things. Okay, you need not to worry about that one. Whatever the thing, whatever the color you want, you can provide that. Okay, any color you want, you can provide. Yeah, I'll go for any other color again. Yeah, this is for differentiating the parts. Okay, now we need to convert this body into what component. Okay, then we need to add the properties, right? That is properties. Here the properties what part number is 7, part name is what Tommy bar. See, Tommy bar, right? And now you can close. You please save this part in your project. My project name is what? Medini VT. Okay, Tommy bar. Yes, save. Okay, thank you. Now I will show you how to do the assembly of this screw jack. First, you please go for the data panel, which is at the left top. You please open this. Now you open your project. Okay, this is what my project. And here, see, if you mistakenly save any parts, okay, uh, now, as I told you in the earlier, I have created the screw jack folder and all the parts I have saved in this, right? If you mistakenly save that parts, whatever you created out of this folder, right? At that time, you can move this the part files. Okay, here I will select Tommy bar and I will hold control. I will select CSK screw, right click, move. Okay, you can easily move it. Here, I want to move those two parts to the screw jack, that is folder, move. Right now, see, if I open screw jack, all the parts are what here. See, before starting assembly, what you need to do is you need to save this empty that is design. Okay, then only you can insert the parts. Control save. Okay, that is assembly. Screw jack assembly. Okay, jack assembly. See, design name save, that is screw jack assembly. Now we will insert a part one by one and we will assemble it. See, the first part, that is body. Okay, now you just drag and drop it. Okay, you select the body part, you hold the mouse button and you just drag it, drop it on the canvas. Okay, like this. And the part when you insert it, right, it will be at the origin only. Okay, and here you can observe here. See, you can move this particular the part which you have inserted along 3 translational direction and 3 rotational direction. See, along XYZ translation and XYZ what rotational direction. If you want, you just move it. Otherwise, you keep it like this. And see, when you go for the assembly, right, it is very good practice that if you fix, you need to make a ground of one part. You need to fix one part. Here in Fusion 360, I'm going to see how to ground the parts. I will show you. Okay, here how to fix the part. Here, see, body. I'm going to ground it. You just right click. Here you are having one option. See ground. Now see ground. Now it is what grounded. Now I'm going to insert the second part. See second part what in case of Fusion 360 for assembly we need what nut part that I'm going to insert it. See like this. See when you insert that part right that will be what inserted at the origin. Okay. Now what you need to do is you just drag that parts here just by holding that arrow mark. You place it to proper position. You click on OK. And here see in most of the cases in Fusion for the simple that is assembly will make use of only the joint. Okay, you click on see you select that joint. Okay, here what I need to do is here you need to select component 1 and component 2. Here the component 1 I will select see this one that is that part. Here I want to assemble see this part. Okay, see component 1 selected. This is component number 2 second. See if you want here see if I take front plane right see it will be better. Okay, at the same time here you go for the motion. Okay, in Fusion 360 you can provide the motion in between the two parts. Okay, here there are so many types of motions are there: rigid, revolute, slider, cylindrical, pin slot, planar, ball, like that. I think you all studied about this type of that is movement, that is kinematic movements in that is kinematics of machines or dynamics of machine subject. Okay, here I will explain four that is uh, joints. Okay, rigid joint means what? Here you can't provide any motion in between these two parts. If I click on revolve, right, here what happens is this particular nut part it will revolve. See, you can observe here. See, revolve. If I click on preview, right, see it is rotating. Only rotational motion it will exhibit. Revolute. Third one is what? Slider. See, will slide. You can control this distance also. Okay, minimum and maximum by setting minimum and maximum. And after that you can go for the cylindrical. See, in cylindrical both sliding and rotational. Both sliding and rotational. See like that. See, some other joints are there. See, pin slot, planar, ball joints. Okay, but here in the screw jack assembly, in between the body and nut part will exhibit only that is rigid motion. Okay, that is rigid. Click on OK. See, 2. Now we'll go for the third one, that is screw spindle. You just drag and drop it, and you place that screw spindle to a suitable position. See, like this. It is at the origin. Now we'll move it little higher. See, like this. And now I will click on. See, previously what we selected the edges, right? Now I will show you how to that is assemble by selecting the center point here. See, if I move my cursor here, see on the sides. Okay, if I hold control right here, if I move my cursor to the center here, see the center point. Okay, see this point. We'll select that center point. Now I want to assemble that point to the what here. See that is you move your cursor on this space, hold the control and move the cursor to the center here. See. Okay, because here it is having threads, right? Then it will be very difficult to assemble by using edges. Okay, that's why we can go for this one. And here I will place it to a proper position. Okay, and here in case of screw jack, what happens is this screw spindle has to make a rotational motion, also sliding motion, right? It has to exhibit sliding motion, at the same time it has to exhibit what? Rotational motion. And that time you go for motion. Here you select cylindrical. When you select cylindrical, see screw spindle is rotating and also it is sliding, but it is sliding little downwards. Right now I will set the limits. See, first thing is what? Rotational. It has to rotate for 360 degree. Okay, I will enter 360, minimum 0, maximum 360. And after that here slide, it has to slide. minimum 0, maximum value I will take 50. See, no, not up to this distance. I will take 120. See, 120. Yeah, now it looks good. Now here you please select this. See, all limits. Means what? At a single instant, it will exhibit both the motion. If I click on preview limits here, it is rotating. At the same time, it is what? Sliding. Right? Now you click on third part. Okay, that is twist spindle over. Next part is what? That is cup part. You just drag and drop it, and you place the cup part to the what? Top. Okay, it is at the origin. Now you just move it to the top so that you can easily assemble. Click on OK. And here assembling this cup part to the screw spindle is very easy. You go for join, select this edge. Here, this has to be assembled on this. See? And now see, previously we selected cylindrical, that's why now default is cylindrical is there. But I don't want cylindrical, I want rigid here. Okay. Yeah, rigid. Okay. Now we'll go for the next part. See, the next part is what? That is washer. Just drag and drop it on the canvas, and I'll move that washer to the top here. See, click on OK, and now I'm going to assemble that washer part. It's very simple. Join. See, this edge, it has to be assembled on. See, yeah, like this. Right here, you just if you want, you take a top view, you can observe. See, it is exact at the center. See, you just tilt it, and now you click on OK. See, it is the wash. Now CSK screw, right? See, you just drag and drop it, that CSK screw. Okay, you place it to a proper position here. See, like this. Just move it to proper position, and I will rotate it. Okay, see this. I will click on OK, and now again joint. See, here if I move my cursor right here, see, since here thread is there, that's why it is difficult to select here. Now what I will do is I will move my cursor here. See, I will move my cursor on this particular face, and if I hold control and if I move my cursor, see, center, I'll get the center. See, this center, yeah, it has to be assembled on this. See here, face. Here I will select this sets, hold the control, this center. Okay, see, yeah. Here you please check. Yeah, it is at the see, to the top face. It has been moved. Now what you can do is here in Fusion 360 you are free to place it to any particular distance here. Okay, see, like this also you can that is assemble it. Okay, see, you can observe for 4 mm. Okay, 4, or else you can move it a little higher. Okay, 4.2. Yeah, that is I will take 3.9. Yeah, it looks good. 3.9. Yeah, or 3.8. Like this you can adjust. Okay, or else you can do one thing. See, I will come back once again. See, I will come back like this. Once again I will assemble it here. See, joint, I'm going to assemble it. See, this face and this center, right? See, now I'll go for here. Yeah, see this face, see this center. Now you can observe, see, it is at the exact position. Okay, you click on OK, and now the last part in screw jack assembly is what? Tommy bar. Now I'm going to insert that. Okay, I'm going to insert that Tommy bar. Just drag and drop it, and I move it to a proper position, and see, like this. Okay, if you want you can rotate it, or else directly you can assemble. To go for joint, see, this cylindrical, See this middle level select. See this middle. Okay, and here you just move the cursor inside, and here you want this middle. You hold the control. Okay, you hold the control and this middle. See, place it to a proper position like this, and see if you want any you want to move outwards or little forward, you can move it. Okay, here 10 mm is there. See, like this, you can move it inside. See, like this, little forward. That's it. See, this is what the assembly, right? And now see everything. See, all the parts assembling is also over. And here you please observe. In the assembly, you are having one command that is motion link. Okay. See, previously what we did is while assembling the parts, we used joints, right? Okay. Why we used joints? Now I will show you. See, by using that, what we can do is we can exhibit, we can show the what is the purpose of the screw jack. It is mainly used to lift the load, right? Now, here you please go for joints. You open the joints here. Cylindrical joint is there, right? Okay, here you open this assemble motion link. Okay, if you select this cylindrical, it will ask you, see, link with same joint. Yeah, I want to link with same joint. Here you can observe. See, now see, little bit I will go for the distance. I will increase it to 200. See, like this. See, you can observe. Yeah, I will take it out. See, see, this is what the purpose of that is exhibiting the motion between the parts. See, so that the people can understand what is the purpose of the model what you created. See, you click on OK, and see, whenever, see, if you want to show the motion, right, please come back here. See, open this joint folder. Here you just right click on the motion link. See, edit and play. That's it. Animate. See, it will animate. Okay, thank you. See, the last part in screw jack assembly is what drafting, and now we'll show you how to do the drafting in Fusion 360. See, you please change the workspace from drawing to design to drawing, and here from design. And here you please observe. See, if I click on automatic, right, automatically the sheets will be selected and everything. Then if you click on OK, we'll get a A4 sheet. See, if you want to select any specific sheet, right, at that time you should go for here. See, whether A4, A3, which set you need, you please select it, and units and standards, and also here template. Actually, when you go for the industry, all the companies, they will have their own template. Okay, see, if you want, you can create your own template in Fusion 360, and you can save it, and you can use it for when you go for the drafting. And here, if you won't have any template, default template, it will be provided by the software only. But here I have my created one template. Okay, I will select that particular template. I will click on OK. And now we'll move to the drafting that is workspace. This is what the drafting workspace. And here see, if you want to change that is scale. If you want to scale, you can scale it. Here see, if you want to see, if I take 1:2, see, the size will be very high. I will take 1:5 only. See, 1:5 looks good. And whatever the view you need, right, you select that view. Now here see, I need this view, that is the front view. I will click on OK. And I need visible and invisible edges, and I will click on OK. And now I need top view, side view, right? For that purpose, here you go for create tab. Here you are having projected view. Please select that projected view, and you click on this. Now see, this is the top view, and this is the side view, and isometric. See, like this. And see, isometric view we need shaded. That I will take it as a shaded view. Okay. And now see, next thing is what you need a cut section, right? You need a sectional view of this. You go for here, create. Here you are having an option that is a sectional view. You select that, and you select this and now here see, from this center, right? I will draw one cutting plane here. See, like this. From the center I need it. Okay, see, yeah, center. See, like this. I will draw a cutting plane like this so that I will get a the cut section view. See here, this is what the cut section view I need. See, half section. See, I just selected the half section. That I will keep like this. Then I will click on OK. Okay. See, cut section view. Whatever the section you need, you take this. Okay. If you draw this cutting line, if you extend this cutting line up to here, you will get only the quarter section. Okay. Only thing is what cutting planes. If you extend up to here, you will get a quarter section, and I will move this up to here. See, now you want to mention the dimensions, right? See here you are having the tab here. See this one, that is geometry tab, modify tab, create tab in the create tab, and also here dimensioning is there. See, dimensioning. Here you select the dimensioning and you please go for the dimensioning of all the parts. Okay, here see 140 mm. See this one, height, and whatever the thing you need, right? You select all the things here. See the radius, whatever the radius you want, right? Here the radius you select. Okay, here see dimensions. I need a radius. See this radius I want, radius 5. So I want this radius also, that is 10 mm. See, like this. Okay, you go for dimensioning all the things. Okay, whatever the things you need it, right? You just go for the dimensioning. See linear dimension. You select linear dimension. See, same thing. See this. Now the dimensioning. Okay, whatever the dimensioning you want, right? You just go for all the this dimensioning. So this is 50, but here I want to measure the this top. See, from this top to this. Okay, see. Here also see. Just go for dimensioning of all the parts. Okay, like this. Okay, and if you want to put any GDT, you can make use of here. See, symbols are there, surface texture and everything. See, welding symbols, everything are there. You just make use when you go for that is GDT, the center line and everything. And now finally what we need, that is tables we need, right? So you go for tables. Here you take parts list. See, parts list. Whatever the parts list you need, right? You see, this is what the parts list. Okay, and you please drag this the bubbles inside. Okay, see, it should be within A4 sheet. See, like this. See, like this. And now here you can observe. See, item is there, quantity is there, part number is there, description, material, and if you want to customize this table, right, that also you can do. You just double click on this. See, I don't want this a description. See, I will remove the description. Okay. If you want to add anything, see, if you want to add any, see, I want to add mass. See, like this. Okay, whatever thing you won't need, right, you just add that. See, this is what the parts is. Now, see, finally, what you need to do is you need to take a printout, right? At that time, you need to export this file. Okay, at that time, you can make use of your export option. You please click on this export option. Here it will ask you, see, open in PDF, right? So now I want to open in PDF, but at the same time I want to save it. So you click on OK. See, it will ask you the location where you want to save. See here in the cloud, I want to save this file in Medini_VTU and Screwjack folder. And here, see, where I want to save in your computer. See, I want to save this in my local disk in a desktop. In desktop, I have assembly folder here. Okay, assembly photos. Okay, I'm going to save here. Okay, see, this is what the assembly. Okay, then you click on save. See, now what happens here, that particular the drafting what you have done here, see, it is available in PDF. It is open in PDF. At the same time, it has been saved in cloud and also in your the local disk, right? In local drive we have taken this assembly photos, right? See, assembly photos, Screwjack here, see, assembly PDF here. So in local drive also Absolutely. This you can take it as a printout, right? By mentioning all these things, you can take a printout. See, this is all about how to do the drafting and how to take a printout in the Fusion 360.